Okay, good morning, everyone. I'm going to introduce you to logarithms today. And for that, you're going to need your assignment 2.3, which you should be able to find in the front of the room. All right, so let's go look at that. Share our assignment. And there it is. We don't need my smiling face there. All right, and here's our assignment 2.3 Introduction to Logarithms. All right, so to start with, we have a quick review of where we've been so far. All right, so we had these two forms of exponential functions that we used, and we had a starting value. And so if we remember our vampire over here, we started with 4 vampires. The rate of change was 2. Look, it's doubling every time. So times 2. So we had 2 right there. And then we're going to use an x. All right. And this is, and we're going to call this f of x this time instead of t. All right. And so there's our rate of change. And I want to introduce you to a new word. Not a new word for you, but a word that means something a little bit different. So rate of change and base are the same thing. All right. And we're going to use this base. The word base is important when we talk about logarithms. All right. So we don't really talk about rate of change. We use the word base. It means the same thing. All right. So let's build a model function for these tables. Let's walk through this one. All right, starting value. Here's our starting value right here. Notice when time or number of things we did was 0, that's our starting value. So our starting value is 2. We can divide these. Notice this is growing. This is a growth function. All right. And so we're going to divide 4.5 by 3, and we're going to get 1.5. And so that means our rate of change, also called base, is 1.5. And so our model is going to look like this. F of x equals starting value times 1.5 to the x power. And if we want to find f of x equals what happens when f is 11, all right, so we're just going to say what happens when x equals 11. All right, so f of 11 is going to be 1.5 to the 11th power, and we're going to put that in our calculator, which I'm doing right now. First, I got to find my calculator. There we go. 1.5 to the 11th power, and that gives me 172.995. I'm going to call that 173. I'm going to round that off to 173. All right. I encourage you to do this one. Let's do this example yourself. Notice that it's a decay function, which means your rate of change is going to be less than 1. So pause the video and give that a try. All right, let's see if you got the same thing that I got. All right, so starting value is where x equals 0. So that's going to be an 8. And then I'm going to take these two, 4.5 divided by 6. All right, and I put that in my calculator, and I get 0.75. Okay, that's what I was expecting, because a decay, remember, decay is going to be less than 1. And I have less than 1, so that's good. All right, and so that means our rate of change, also called our base, is 0.75. All right, so our model looks like this. F of x equals 8 times 0.75 to the x power. So f of 8, so we're going to put an 8 right here. So what happens when x equals 8? All right, and so that's going to be 8, 0.75 to the 8th power. We're going to put that in our calculator. 8, 0.75 to the 8th power. And that's going to give me a 0.8 and a bunch of other decimals, but I'm just going to call it 0.8. All right, so hopefully yours came out the same way. What about when we're finding an inverse value? Inverse value. All right, so up here I said, what is y when x equals 11? Here's the inverse question, though. If y equals 50, what is x? Or over here on a decay function, if y equals 1.5, what is x? And to find that out, we're going to learn about logarithms. All right, logarithms. And here's our two examples. All right, and we go through the same process. We find the starting value, which is 1. All right, and then we divide 4 and 2, and we find out our base, right, or our rate of change is 2. And because this is a 1, it's an invisible 1, right? So I didn't write it in there. You don't need it. So in this case, now notice we're going to, since they gave us a y value, we're going to write this as y equals instead of f of x equals. All right, so when y equals 2 to the x power, and now we want to know when y equals 50. So instead of changing the x, I change the y to 50. All right, and now we're going to use a wonderful thing called a logarithm to figure that out. All right, now we keep the base. Remember I said this was the base. All right, and we write this log base 2. That's what this is called, log base 2. All right, so we just write that in, and then we switch the x and the y. All right, so the 50 goes over here, and the x goes over on that side. And on your calculator, you can find a key, which is a log key. It's right under the second key at the top of your calculator. And when you put in log base 2, input 50, you get 5.639. Okay, so now that's our answer. Y will equal 50 when x is equal to 5.6439. All right, let's go through one that's a little bit more complicated. Here we had our start value was 1, so that made it pretty simple. This one's going to be not quite as simple because our start value is going to be 32. And it's a decay, so my rate of change or base is less than 1. All right, and so here we are. I have 32 times 0.05 to the x power, and I want to know what is x when y equals 1.5. All right, so I'm going to put in 1.5 here. So I'm going to change y to 1.5. And I'm going to do the same thing, except first, notice I have this 32 in front, okay? So I can't change this to a log while 32 is in front of my exponential. So the first thing I have to do is simplify this. And notice I divided both sides by 32. Also notice I left this as a fraction because I don't really need to change it, you'll see. All right, so now I have that. Now I go through the same thing. Keep the base, all right? In this case, base is 0.5, and switch x and y. All right, so that 1.5 divided by 32 is going to go over here. And I can put this in my calculator just like this. So I can put a fraction in or a decimal as the base, and I can put a decimal or a fraction. All right. You can hear all the announcements on this video also. All right, and so when I put that in my calculator, we find out that y will equal 1.5 when x is equal to 4.4. All right, so back up here, if x was 4.4, y would equal 1.5. All right, here's a little warm up for you to try. So please give those a try. All right. And we'll go to the back here. We'll do a couple of word problems. All right. If you remember, these are from last week. You already did these. So you already figured out what this model was. All right. And the model was, except we're going to say y equals this time. So the model was 30,000 times 1 minus 23%. And we're going to use x's and y's instead of t's. All right, and we're going to want to change this to a decimal. We could leave it like that, but it's a little messy. All right, so if you put that in your calculator, you'll find out that it's 0.77. All right. And so now our simplified version of that, and we want to know when will the SUV be worth 5,000? All right, so y is going to equal 5,000. All right, so we're going to rewrite this as 5,000 divided by 30,000 equals 0.77 to the x power. All right, and we're going to keep the base. So this base was 0.77. Remember, I said we can have decimals or even fractions as a base. And I'm going to put 5,000 over 30,000 here. And I'm going to say that x equals that. And so I'm going to put that in my calculator. And let's see, log of 0.77 and 5,000 divided by 30,000. And that's going to give me an answer of 6.8. If I rounded it, 8.6. And so this was how many years? 23% per year. So my answer would be 6.8 years. All right, and so finish those on the back here. All right, and then you have a Delta Math assignment right here, which is 2.3 Introduction to Logarithms. There's 10 problems that you need to complete on there. So good luck with those.